All right.
Hi, I'm Eno.
I'm Jason.
So this episode, our last episode, we did some cleanup of our packages. As it stands right now, every time we hit our webpage, we're going out and we're hitting the Meetup API. So for this episode, I think we're going to put together some kind of cache, such that we don't have to go out and hit the Meetup API every time.
Yeah, so every request that's being made to the server is then spawning up multiple requests to Meetup's API, which they probably don't appreciate that type of load. So basically, we're going to have a cache that we'll have a Go routine that wakes up every 24 hours or whatever, makes those requests to the Meetup API, then caches that result, and then all of our HTTP requests that hit our server will just read from that cache. So.
Yeah, and depending on how fast it goes, I think if we have a little time, maybe we'll get to this second point in our to-do list here.
Yeah.
Ordering event data by timestamp, maybe some cleanup there.
And then maybe clean up some of the presentation of the data, and then we have a kind of a PSD layout of the website that we probably want to show off.
Yeah, cool.
So,
and we'll do all that CSS off camera. And next episode, hopefully, it will be all put together. We'll see.
All right, so we want to start.
So
kind of feels like a data concern. Want to stick it in the data?
It does. What does main.go look like? It's been a little while since
Very
we
lightweight, from what I remember.
since we looked at that. All right, so we're just starting a server. And how does the server get a hold of the data? We're not injecting anything in there, are we?
Let's see. So server builds up his own servmux, and then
Oh, I see. They're on
this
like
index handler.
25. That's where we're newing up the data store.
Yep.
So one of the things that I like to do is start from the outside to describe like the API that I want.
Yeah.
So I would be tempted to say, let's take this data store and promote it as a parameter to this index handler, and then thread it through from start. And then that way the idea that I have here is, let me pull up main here. From the top level, I'd imagine that while we have the server running, that we have some kind of cache. Like I would imagine something like this, and it's probably a data concern, as you were saying. Maybe we have like a new cache. Oops, let's see if I can remember how to type. It's been a while. And maybe here is where we inject like some kind of frequency, time.hour.
Yep.
And that's a cache. Oops, we'll do this, and then we can say go cache.sync, and then we'd inject the cache into our server.
Yep.
And it would have some kind of like, give me the data, something like that. What do you think?
Sounds good. So, do you want this server to be a proper type? Because right now it's just a function, again, the server package. So we can say server.new, and then it would have state so it can hold on to its cache. Or we could just receive it as an argument here, and then pass it along into the handler.
So, I once had a conversation with somebody talking about static methods and instance methods, and that conversation has kind of been a guiding design principle for me ever since. So we just kind of take a step back for a moment and stop thinking about start per se. If you're doing a lot of static methods, or like this could easily be a static method. Like we could easily call start, but we're in a position where if we ever wanted to have any state in our server, all of a sudden we have kind of like either introduce variables in the package, global variables in the package, which is not super great, or I don't even know, do some kind of finagling within start. So to me, it feels like it would be nice to be a type. That's a long-winded way of saying I feel like the type gives us the more flexibility to maybe have some state inside our server. But then again, this is Go, so maybe the idiom's a little different. What's your feeling?
Yeah, I mean, I agree with that. What I'm kind of thinking about now is that it's been a while since I worked on this, but we have this data.store thing.
Yeah.
I wonder what that looks like currently, the interface for that. So we have all events. Really, all the HTTP stuff is concerned about is asking something for all the event data.
Yep.
So it looks like this store is already kind of our interface that we want.
It's pretty close to it, yeah.
So maybe the cache could be implemented as a detail of the store, and then we new up the store out here instead of calling it a cache.
That's a great idea. I like that.
New store, or we call it cache, and then we pass that in here. in our server package, we just don't have this anymore as state. Well, I guess we need a state. Yeah, we need a state.
Yeah, you still have to hold on to it. But we can make it an interface. That's what you're thinking.
Yeah, like a local interface in the package.
Yeah.
Oh, fine. Type. We're gonna call it store.
Store is good. I mean, I like the way that Go does like reader writer, but sometimes interfaces just don't have a good something ER.
And then what does this guy return? An event, which is a data concern, so it returns data.events. Cool.
Yeah, great.
And then down here, you would take in a store, which is a store. Let me just call it S. Instead of newing it up in here. This is kind of like a code smell if you prescribe to the like philosophy of like dependency injection. You should you can new up things in a constructor, but you want to do that as like a default. You always want the option of being able to inject your own dependencies. So the store is a dependency of the HTTP server. It doesn't need to be concerned about that. So we should. It's kind of a smell that we're doing up here.
Well, it's looser coupling here too.
Yeah.
So if we ever decide, this store that we wrote isn't very good, we want to write a better store. This guy did this file on the right here doesn't have to change because it's just like as long as you give me a thing that I can call all events on, I don't care.
Alright, not enough arguments call a new index handler, so he needs to pass along a store.
So just a moment ago I was thinking that the start function should be against the server, but the more I think about it, it's kind of nice to have this sort of convenience function for the moment.
Yeah.
Right? Like if you want to get into the guts of turning all these pieces on and doing it yourself, they're all exported types. But if you're just in a hurry and you just want to start the thing, then that's what start will do for you.
Alright, so this package is now allows for us to send our cache in.
Yeah. And I think actually your instinct was right to call it a store. I think we can think of cache as kind of a private implementation
Okay.
of the store for the time being.
Store. And then we'll say s dot poll. It's like the polling loop.
Sure. Yeah, let's say it's the thing
sync,
that...
sync to me is like more of like an active thing. So like go out and I don't know.
Let's do poll.
Yeah.
Either way, it's the thing that's going to go out and fetch the data on some interval.
So we have two Go routines here. We have the Go routine that's doing the polling, and then a Go routine that is serving up all the HTTP. Basically, it's listening on the TCP netcon, and then spinning up Go routines to serve state requests. And then this will be S here. That should be it for the main.
So,
and then we just need a new store.
What's really cool about, I mean, we don't have any tests. We would want to have tests,
Yeah.
but what's nice about having a compiler is we can let the compiler guide us. It can be the kind of tests.
We can be lazy.
We can be lazy.
We talked about writing tests, TDDing all this stuff, but it kind of felt like it would slow us down. So, but yeah.
For the first go, I think we should definitely do an episode on like how we might write tests for something like this. But we're writing this in a way such that it would be trivial to test it.
Alright, so func restore takes in a time dot duration.
Yep.
D, and it returns a pointer to a store. Or sorry, pointer to a store.
Cool.
So it means store is going to need to keep a hold of its, I don't know what I did there, its duration. Let's say
cool.
polling interval.
Yeah, that's good.
Say I. Return a pointer to store. Has a polling interval on. And one thing I want to discuss is why we didn't define the interface here in the store package. So So we define the interface at its use site instead of at kind of a common shared package. So you figure like a store, that's a concern of the data package. But in Go, and I kind of agree with this perspective, really you should have your interfaces be local to the package where they're being used. And that allows you to kind of define the API for this thing. So if someone later on comes along and they want to provide a different implementation of the store, they don't have to kind of reference like some source of truth interface.
Yeah, what's nice about this is that, we're in the server package right now, right?
Yeah.
If in the future we say this data package needs to be rewritten, there's some horrible bug in it. The server can be as is, right? Like it doesn't need to change. For me, coming from doing a lot of Java, this was really weird to get used to at first, because I think in Java you want to have the interface and you declare it in some place and you share the interface in a bunch of places. And so even now when I'm looking through Go code, I notice that like it still seems like people aren't still learning this, that you want to define your interface right next door you're using it. And yet it makes for nice, really loosely coupled
it's all about coupling. When you have that source of truth interface, there's a huge temptation to add to that source of truth interface. Which couples everything together, and then you end up with massive interfaces. So I much prefer like at your call site, if all you want is something that has a all events method, that you just define an interface that receives that anything that has that all events method, instead of referencing something that has like 40 methods, like 39 of them you're not using.
You're going to be, it's not intention revealing too, right? Yeah. Like you're going to look at that interface and be like, what the heck is this thing?
Yeah, like why am I not using these methods if I'm like accepting that interface?
Yeah, right. Yeah, right. All right, so does our main build at the moment? I'm curious about that. Does it blend? It does, great. So it doesn't work probably, but I guess what are we going to say working?
It's interesting that it built because we don't have a pull method yet. So new data. Oh,
there it is. Okay. There it is. All right, so let's just add a pull method now.
All right, so I'm going to go up right below the all events. We'll have a pull method here. Let's see. Maybe just do a little above here.
What's going to be neat about this pull method is it's going to be a lot like what all events is right now.
Yeah, it's pretty much going to be the guts of all events, but in a for loop.
Like shared state.
All events is just going to read off of something.
Whatever that.
So all events is going to get a lot simpler, and all that complexity is going to go into pull. So we say pull runs forever, comma, polling the I cannot type today. Meetup API. For event data and updating the internal cache.
Cool. Looks great. So let's see here. Yeah, we're going to want all that.
Pretty much just rip it all out here.
Just drop it right there and pull.
And we're going to want a for loop.
Yep, just working forever.
Let's do that here.
Cool. And there's that to do, sorting by timestamp. We'll get to that in a little bit.
How about we pull this out into a kind of private method and just say func s pointer to store, and we'll call it lowercase pull.
Okay.
Kind of like doing this just to kind of clean up the for loop. So we just say s.pull will give us back our event data.
All right.
Events, and then we'll update a shared pointer, and then block for polling interval.
So there's
even use that ticker or whatever.
Oh yeah. Well, so there's a couple of questions I want to ask you.
Yeah.
This poll, this little capital P poll, little p poll. Tell me a little bit more about that pattern, because I've seen this elsewhere. I think I've seen this elsewhere in the code base that we've been working on together, and I'm kind of curious about what you like about this pattern. where you've seen it, if there's a history to it, and so on and so forth.
Yeah, there's two instances where I've used this kind of thing. One of them is where you have the first one is when you have like a loop here and you just want to clean the body of the loop. Like I feel like if we had all these details within the body of the loop, you're not operating on the same level of abstraction.
Mm-hmm.
Like this is like pretty clear. I get all the events and then I store them somewhere that's shared by both Go routines, and then I'll wait. Like those are like high level like declarative type of level of abstraction. Whereas this pull details here are kind of like implementation details of acquiring that data.
I really like the point about the levels of abstraction, because I find that's an effective way to write really nice code, right? That, like you were saying,
humans' like mental model of how things like happen.
Yeah.
Okay, this is the first step. This is the second step. This is the third step. They all share the same level of abstraction. If you were to explain someone like how to go from Denver to Boulder, you wouldn't say first take your left foot and put it in front of you, and then take your right foot and put it. But that's what we would be doing if we pulled out all these guts and put them into the for loop. You want to say first you get on the bus, and then you wait for 45 minutes, and then you get off the bus, and then you're in Boulder.
And then you're there. Yeah, that's really nice. I think that's super nice. I think that's such a strong point. The single layer of abstraction, right? And then here's all the guts. Here's all the footsteps. Here's the footstep you have to take, or the wheel goes around, whatever.
Yeah. So that's the first reason why I do that. I also use it when I have a shared. So I ran into this before, where I have a type that's protected by mutex. All the methods are protected by mutex, and there's like a delete method and there's a delete all. And basically all the delete all does is goes into a loop and does all the deletes. But because Go doesn't have reentrant locks, or at least I'm not aware if it does, if I'm holding the lock for the delete all, and I want that delete all to be a critical path, so I can't not hold the lock and just do the deletes separately, because I don't want to interleave things in between those deletes. Then I'll hold the lock for the delete all, and then I'll have a private delete that will not hold a lock. So it's an unsafe delete. It's not guarded by mutex. And then that unsafe delete can then be shared by the other delete method, which isn't the delete all, the delete single.
So it sounds like you got finer grained control when you break out something like this.
Yeah. And there's certain locking situations where, like, are you familiar with reentrant locks? I don't know. Our audience.
I think that's a great topic, but maybe we'll save that for our
getting off.
Save that for our locking episode.
Yeah. Okay.
Anyway, so that's nice. I really like that. That's pretty cool. So let's talk briefly about where we're going to store this data. We're going to probably want to just store it on our store, right? And as you're writing the event this line here, the other concern that we have to think about is the moment we're doing a poll, somebody comes in and says, hey, give me the event. So we have this possible data race, right, where one thing might be writing to the data and another thing's reading. So put a mutex around it, put a simple lock around it. It's a nice simple line,
the
right?
Go convention is to put musync mutex. Just declare that above the data that it's protecting in the struct.
Cool.
And then separate it by a new line. So we discussed a little bit about using mutexes and then maybe switching to some more advanced concurrency primitives. But to be honest, like our use case, like we don't need to be fast.
Yep.
So if you don't need to be fast, like don't waste time optimizing it.
Cool.
So let's go ahead. So we have our place where we're going to store the events, and then we have a mutex to protect us. So let's go ahead and update our share pointer. So let's do s.mu.lock. So this will block until the lock is acquired by this thread, and then we want to unlock, and then we want to say s.event cache is equal to events. And so we don't want to, you could probably say like, oh, why don't we just inline s.poll here? Well, that means that we would be acquiring the lock while we're doing IO, which is like a big thing that you shouldn't do. You should make your lock acquisitions as reasonable as possible to be at a short duration, so that you have lower lock intention.
Yeah, as finely grained as possible, right?
Yeah.
Like the only lock we want to,
I
only
mean-
thing we want to lock is that assignment.
Yeah.
Everything else is fine to run in parallel.
There is kind of a trade-off between lock intention and lock overhead, so
Mm-hmm.
it's not always the case that you want to go finer grain, but in most situations you should prefer finer grain over coarsely grained. So that gives us a pretty fine grain write. We're just doing a single write,
Yep.
single instruction probably, or maybe a bounded amount of instructions. So that's our locking. You can already see, like, we're already operating on a different level of abstraction here. So
Yeah.
I'm gonna pull this out, and that'll allow us to use a defer as well.
Yeah, let's
So
do
let's
it.
go ahead and do
Let's do
that. So func store, and we say update cache.
Beautiful. It's really nice, that like that single layer of abstraction.
And this allows us to do a defer, which I prefer. I prefer my defer.
So I've heard that the argument in favor of defer. I mean, if you ever get curious and benchmark this, the defer is slightly slower. I mean, and by slower I mean like negligible
Yeah.
at this point. But nonetheless, you have a little more safety, and like you're not going to forget to
Yeah.
unlock it. And you know that's a disaster if you're all holding, if one go routine is holding the lock, and nobody can get a hold of it.
And so here we could do inlined s.poll, because that would evaluate first, and then we would acquire the lock, then we would update the cache, the defer
Yeah.
would fire. I like readability over terseness.
Yeah, nonetheless, like step one,
Yeah.
get the event. Step two, update the cache, and step three, wait.
Yeah, and so this waiting thing, I think we should just use a ticker. So time.ticker, I think it is, a new ticker. So this, you give it duration, and it gives you back a ticker object, and then you can range over its channel, and it will put something on a channel every ticker, every duration seconds.
Cool.
So let's go ahead and use that and just say s.polling interval. And then that'll be our ticker. So here we say for range, and we read off of the ticker.c, I believe. Yeah. So that's a chan of time.time.
Yeah. And I think we don't need the read. We can just range over the channel.
Oh yeah. Sorry.
So it's a simple point, but for people who are maybe coming from like a background where concurrency is not a first class concern, this poll will be happening in a Go routine, but it's just the read here is harmless, right? Because nobody is writing to this property. There's just zero problem.
Oh yeah,
with-
yeah. You only have data races when you have at least one Go routine or one thread, one concurrent actor writing, and then one reading. If you have no writes, or your writes were done at a defined time and your reads are separate from that time, then you're safe as well. So you have to have the concurrent write and read. That's when you get into trouble with data races. But
Cool.
this we're not
Looks
running
good.
into that.
Looks good. So we have a very nice abstraction, single layer of abstraction.
Mm.
The polling needs to change just a touch.
Yep.
We're going to need to update the signature on 53. Or I'm sorry, you're looking at all events. I'm looking here at poll
Oh,
here.
yeah.
One little thing on 53.
Yeah, we
we
need
just
to
want to
return our slice of
hand
events.
them back.
So let's see if we build. We're not going to build because all events is returning nothing. So just return nil, see if we build.
Cool.
Alright, so we're building. So all events is obviously going to have to read the data. So let's go ahead and do that. So we take out our mutex.
Yeah, and this will be beautifully simple because we've separated all our concerns. And
I don't know what happened there. There we go. So, and then we just return s dot, what do I call it? Event cache. Alright.
cool.
So that should just work. I kind of wanted to, before we do some manual testing here, I kind
Yeah.
of want to just do a pat once over the polling.
Yeah, let's talk through it because I think there is the case where this request to acquire the lock, might actually take a while. It's probably a rare edge case, but let's talk through it here.
So yeah. The lock acquisition, so basically the readers, so our writes are going to be very infrequent,
Yep.
once every 24 hours or whatever, and then our reads are possibly very frequent. So what we could do here is use a read-write mutex so that those reads aren't contending for the, basically read-write mutex works in that reads can happen concurrently, safely, and
Yeah,
then...
so person A comes in and says, hey, I want to see this stuff. Person B comes in at the exact same time. They'll both not have to wait for the lock.
Exactly.
They'll be
Yeah.
serviced in parallel.
Yeah.
Right?
So there's that. I'm not too worried about that. I think that's like another like premature optimization. And then I don't know. Is there anything else you wanted to do?
See, well, the other thing I was wondering about here is I think this code is fine. It's just worth. I think when a person starts using mutexes, it's worth kind of taking a second pass and just thinking a little bit about it here. And I know that I've been bitten quite a few times by concurrency. I mean, concurrency is hard. That's the root issue. Like our human brains aren't wired to think like that. But let's see here. If we came back up here, let's just talk through a very simple case here. So the cache is going to be updating, but in a case where, well, here's what I'm wondering. Do we have a timeout when we go fetch the events? That's really what I'm wondering. Because the API just didn't respond.
Yeah, so if that happened, then our polling loop would be blocked. But because we're not doing the polling while we have the mutex acquired, since these are separate, then the reads can still happen without being blocked.
So that's really such an important point,
Yeah.
right? Because if the API server goes down and starts like having really slow, like latency goes up, it's taking 10 minutes for reads to go through. I mean, I don't think that would happen, but nonetheless,
It could.
in some cases it might. You don't want to be waiting. You don't want to be putting your lock around that IO like you're saying again. I guess really the point is this is more just to emphasize the IO point that you're making earlier. So we're totally safe from the idea that one day the API server takes forever. We're still going to service our clients. Granted, the data would be old, but nonetheless, data is going through.
It's a really important point is holding locks open while you're doing IO is a bad idea. Holding locks open when your thread's going to sleep, like if you do like time.sleep or something like that, with a lock acquired is generally a bad idea. So yeah, I mean, those are things you just gotta reason through as you're using mutexes.
Yeah, and even then...
Did you want to go through and change this to read-write mutex? Yeah, I mean, it wouldn't hurt. It's kind of just a small optimization. It's up to you.
Well, let's leave it. I think
Okay.
I want to revisit the read-write stuff when we talk about locks,
Okay.
mutexes, and atomics, and so on.
Sounds good. All right, so let's do a once-over of this polling method. You do the time starting by timestamp. So I wasn't really happy with what we had here, but I didn't really put a lot of thought into like how to make it better. So maybe just take a few seconds.
Yeah,
here
it does
to
feel
do
a little bit convoluted. So it'd be nice if we could figure out how to clean this up. Let's do a quick read through, and then maybe we can do a manual test, make sure it looks good, and then we can talk about fixing this up. And maybe, as I know, we want to do the timestamp stuff sorting anyway.
So we have two channels here. One is a signal channel, and then one is like a data channel. And then we have this slice of event data that we're using to kind of aggregate all the results. We spin up a Go routine that will read off of the event channel and then append onto those all, and then close its done channel to signal that it's done. Take out a wait group. We range over all the meetup names, adding to the wait group, spinning up a Go routine to capture the events, and then let's see. Wait until all of the Go routines are done. They probably rate group decrement in events here. Yeah. So we wait for all those guys to be done, and then we close the event channel, which will unblock this guy to close his done channel, and then we read off the done. I don't know if there's like a easier way of doing it. It seems like kind of a complicated way of doing it. Possibly so. MVP though, we're just going to get something out the door, and then we can make it pretty. So that not all this code is perfectly good. Small question. I was looking at a talk that Dave Cheney gave recently. I think it was maybe at the Singapore Go conference where he's talking about channels and how to clean code up. And I think he was using semaphores. Is this done channel in effect a semaphore? So semaphore is kind of like a concurrency primitive that allows a certain amount of threads to acquire like a resource. So the canonical example, I guess, is like a thread pool. where you have a pool of resources, and every time someone acquires something from that pool, you decrement the semaphore. So the semaphore could be initialized to like a value of 10, and then say 15 threads are trying to like get something from that semaphore. Then as soon as the semaphore gets decremented to -1, then the other guys have to wait until the semaphore is incremented.
I see. Okay.
So I'm not sure how it was Dave Cheney.
Well, yeah, and he wasn't saying
using it.
necessarily. He was using a semaphore. He was putting stuff in a channel. It was quite interesting. Maybe we can look at that at another episode. It just popped out.
Yeah, I haven't seen that patterning go. Using semaphores as signals. I've definitely seen the channels as signals. But that might. I mean, Dave Cheney is awesome, so that might be a better way of doing it. Yeah.
Anyway.
All right.
All right. So let's do our manual test and see how it looks.
So go on main.
All right. We have a mistake. A little thing.
All right.
So it looks like new store is the thing that's upset about.
We have new store up here. We have new store, time duration pointer store.
And we are on the data package. Well, what is that compilation? Let's look at the compilation error.
Yeah, let me just quit out of this.
Undefined data in new store. That's the problem. Oh, so you just need to do a write and let go imports to figure out that data is
okay.
in our project here. Cool.
Let's make sure it builds. Go on main.
Great. We're going to do our really cool test. So here's what's interesting. I think we might have a little problem. Let's look at our sweet little application first, though. No events. So we got to just prime the pump, right?
Yep.
Put something in the cache before we go.
Yeah. So I guess the ticker doesn't fire immediately.
Yeah.
So we'd have to wait a whole 24-hour period before it fires.
Yeah. So
that's
the
easy
thing
to
is,
fix.
let's go in and do that.
So down here, instead of waiting for the ticker to fire, we can just do this up here. That's one way of doing it.
Yep.
So it will immediately poll and update the cache.
I think that's the way to do it.
There'd still be a window in which you can get an HTTP request in when the process is starting up. Because in the main, we spin off a Go routine to do the polling, and there's no guarantee that the HTTP request will be after the Go routine's poll here.
Yeah.
But it's such a small window, it's not worth worrying about. So we could do that. That's a little bit like, I know a lot of people have kind of issues with this, like doing the contents of a loop outside of the loop just to get it initialized.
Yeah, to initialize it.
So instead of doing that, you could probably write to the ticker. I don't know if they allow that.
I think I think we leave the ticker alone.
It's a channel
of
time. Or
you just like put something in it.
Yeah, just like do an initial write into it. Let's see what it's initialized
Oh, that's
to.
kind of interesting.
So they make a chan with one element. Let's go ahead and do it. I mean, I don't see why not.
Yeah, sure. Let's try it.
I mean, this also reads pretty well, so I don't.
So there's a couple options.
Yeah.
I mean, as always.
Time.meow. Yeah.
Cool.
So that would work. Invalid. Can't write time now.
Send or receive only, which is good. That's a good API, right? They're not letting us break it.
They're not letting us get out to initiative.
So I think that's a good thing. You know, another thing I could imagine is maybe when we new up a store, we immediately initiate the request. Although I don't really like doing network I/O and constructors. I feel like constructors should just be handing back objects. Another option would be to maybe make one of these. We'd have to do some renaming perhaps, but make one of these private methods public and make it a responsibility of the clients to know how to initialize the store to like prime the store. But from an API standpoint, I feel like you wouldn't want to burden your clients with the responsibility of, what do you say, like filling up the cache, right? Like you should just be able to call it poll. There should be data in there. So I think this is fine.
Another thing we can do, I think we should do this. And I think that'll just work for most cases, but I have another thing that we can do.
Right.
So let's go run main, hop over to here, run our thing, so we got our data.
Oh, and you know what we also have to do while we're here, before we get into this other thing, Well, actually, do you want to just show us the other thing? I'd like to see the time change in the request time, because we're going to see, like, initially it takes so many milliseconds when the server first comes up, and the subsequent request is maybe faster and so on, just to see the benefit of the cache.
Oh, yeah, because we were taking 100 milliseconds, I believe, last episode.
So
let's see, like, how, let's benchmark it, do a little tiny benchmark. So the other thing I was going to bring up is, instead of returning nil here, we could hold the lock open until, or keep on acquiring the lock and releasing it on like a interval in the read, and then wait until like it becomes non-null basically, or a timeout happens. That way, like when you're starting up, there's not this like kind of like, it's not a data race, but it's a race in which is the HTTP request going to be scheduled first, the handler for the HTTP request, or is the polling go routine going to be scheduled first? It's really a micro concern here, micro optimization.
It's worth. I think it's worth thinking about. This particular application is not going to be a high performance thing, but when you do get into the high performance world, like these small little details are super important to think about. So I say let's call this good for initially, and just see if we can.
Let's do our go run.
Notice the difference.
Let's do time. So that thing's polling in the background, and we do our curl of localhost 8080. I think that's just it, right?
Was it 8080 or 90? Yeah, it is 8080.
So instead of taking 100 milliseconds, it took 54. So you cut it in half.
Well, that's kind of cool.
36, 33. Cut in a third, maybe?
Yeah, that's cool.
Yeah.
Well, an improvement. And, the nice thing here is that we're not hammering the API server.
Meetup's not getting all these, like, unnecessary requests. The downside, of course, is that it's a cache, so it
could be stale.
Yeah.
So now it's just a matter of, like, what's a good value for the cache? Like, in my mind, maybe every hour. Like, what's the worst window? If somebody changed a Meetup page, you're excited about going to the next Meetup. How stale are you willing to accept?
Maybe 10 minutes.
Yeah, so... Yeah, cool.
That's reasonable.
Cool. And what's nice is it's configurable. So if we realize 10 minutes is too small, too big, it's easy to change. Cool.
So that's that. We could kind of demonstrate under, we have other things that we want to accomplish this episode. So let's go back to our README here.
Yeah, so we got our polling done.
Yep. So you want to do the timestamp?
Yeah.
Recording by timestamp?
And what's neat about that is, since we'll be going through the poll method in effect, there's no reason for us to spin up 3 Go routines and do them in sequence necessarily. Right? Like, there's no reason why you couldn't just do this sequential. I suppose if we had more meetups, you'd want to get them as fast as possible. Let's see here.
Oh, because it's in the background. There's no
it's in the background.
Yeah, I agree. We could do it serially.
Which maybe takes some of the complexity out of the code.
Oh yeah, it certainly would.
And
we could do that. I mean, that's perfectly valid now because we're doing all this in the background. It doesn't really block the HTTP requests. So.
Yeah, we have some leeway. Before we do that, though, let's talk about where we'd want to put this ordering. Because in my mind, the responsibility of this method is to go out and get the data, however way it's going to do it. So I'm a little bit ambivalent about where the ordering, like it's like a presentation concern, right? Like if you're just saying here's some raw data, maybe sometimes we're going to want to show like oldest event first because maybe you're interested in looking at the history of meetups, or maybe you want to see the newest first. That sorting thing is something that we maybe don't want to be doing in the data level.
I don't know. Do you think it's strictly a presentation concern?
No, not necessarily. I mean, because if you, for instance, like query a database, right? By default, it's going to have a certain order. It's always going to be ordered.
Yeah.
So we could say that that's not presentation.
Yeah. So in my perspective, what we're doing here is, to use your analogy of like a SQL database, is that we're adding a order by clause.
Okay.
To this query, so that we're guaranteed whatever comes out of this is going to be consistently ordered over time.
So
we could use that new slice.
Let's do it.
Slice.
That's exactly what I was thinking. Well, let's do that. So looks like we're doing the assignment to all here, right? We're going out and getting all the data.
So basically, by the time done triggers, like we're ready to
have
sort.
it. So we'll say, okay, so I haven't used this API yet. This is exciting. So I think, is it all, and then we give it a function that defines, I don't know what this API is.
Yeah, you got me.
Let's take a look. How do I jump to definition in your?
Go ahead and write the file, and then it should just be GD.
It is slice, no?
Sort.slice, not
Sort. Oh,
slice.sort.
jeez, yeah. It doesn't make any sense. That's the problem with.
I think it's sort.slice.
Yeah, there it is. That's the problem with trying to code and talk at the same time. All right, so it's going to take the collection, and it's going to take a less function. Not guaranteed to be stable. Use slice stable. What is
that? Stable. That's you've been reading that algorithms book, right?
Yeah, consistent.
So do you want to explain what stable?
No, tell me. I don't quite follow it. Yeah. No, I care. Tell me. I don't understand what stable means.
Stable is if you're giving like an array of values, and say you have 9 in sequence.
Yeah.
That those 2 9s won't be reordered.
Oh, I see.
Like so from the algorithm's perspective, like you could have a non-stable sort where those would get reordered, and it's basically the same thing.
Yeah.
But from if you're not using integers, if you're using a complex data type, reordering of those things might have a consequence. So if I give you this stuff, like you give it back to me sorted stable, then those 2 values that are equal won't be reordered.
So what do you think we should use for our sorting here? Like if we had 2 meetups that happen to be happening on the same day, same time.
Oh, I don't care at all if it's stable. Yeah, that's what I'm saying. Like we didn't have to explain it, but yeah.
All right.
Yeah.
So let's see here. The function for a stable sort's given this the provided less function. So all I need to do is define what constitutes less than.
Yeah. So just takes I and J, which are the indices.
And these are let's see. What is the type here? Oh, I see. Oh, and then I need to do a lookup on all, do I?
Yep.
So I'll return I is less than J.
And then you want to pull a timestamp off of it and see what the timestamp is.
Oh yeah, right. So all is
an event. And I don't know if the event has a time field. Yeah, in 64.
Okay.
I believe that should work.
All right. Let's see. I mean, granted, this is a perfect case where you'd want to have unit tests, so you could test it and you'd know right away. Whereas we're going to be a little bit like cowboy coders here and just
let's see.
Didn't get it quite right. Didn't build. Oh, because my function doesn't specify that there's a return value.
Yeah,
Let's see here. So let's see how that builds.
Cool.
And how are you running this guy? Were you just running
just Control Z on Vim.
Oh yeah, that's cool. So for all the curious viewers, this is the trick that I learned from Gary Bernhardt, where he would just be in Vim, write some stuff, Control Z to suspend, run some tests. That's a very nice workflow in my opinion. Whoops. Well, that will work. So let's look at it here.
There's a delay there when it starts up before it logs the listening on mobile host.
Yeah, let's look at that. Let's look at that next. So we're gonna look at that.
That's what we want.
So I don't really know if those. What are those? Like it looks like oldest, or rather, what's coming up soonest first. So that's exactly what we want. Cool. We might also do a little formatting on the dates. Let's see here. But let's look into that little logging thing, because that was kind of weird, wasn't it?
Yeah, I don't know if it's super important, but so this guy could have been scheduled, and if it's on a single, I don't think that's it. Really, like it should happen almost immediately. Oh, it's build time. That's what it is.
Yeah.
We're doing go run and it has to compile the binary and then run it. So if we did a go build and then ran website, it starts immediately. So.
Cool.
All right. So we got the sorting done. You want to do a commit for that?
Yeah, let's do a little commit. Maybe we can close out the episode putting a little bit of love into the presentation of that date. Maybe make it a little more human readable and call the episode there.
Yep. And then we wanted to show the...
Yeah, and let's show the kind of mock-up as sort of a preview for our next episode.
So let's go in and data. So we can do a few different things here. Event currently is just an N64 because that's what it is in JSON. They give us a integer. So you could convert that to an actual time, and then just use the native formatting.
Yeah. What would that look like? Would we need to do implement our own unmarshaled JSON function? So I think that's an interesting thing to do. I think because the event comes back from the API as a Unix timestamp.
Let's see if time just works.
Okay, yeah, that's a good question.
Because it might.
It might just work. Yeah, let's check.
I've never done this before, so go run.
Oh, we got a.
Oh, our comparison's not working anymore. So let's go up there. We should just do. Here's a method.
Yeah, what was that? After or something like that, or is there before?
I mean, it's inverted. So we'll see what the result is. So parsing that string as a
Yeah, it doesn't like that. This
It
is the
wants that.
what is this? There's a
UTC,
ISO
yeah,
standard
like
here
that.
for this.
So it doesn't like that. So
What is is time.unix a type? I know there's a Unix function, but it probably returns just an int, doesn't it? Oh, it does do a time.time.
So we could do is just say UN64. I think that's what we had
Yeah,
before.
so-
Or N64. And then we can convert it in the presentation layer.
Yeah, I think that's exactly right. I find that
So
when you have a
it's-
type that's there for
this.
like binding to some JSON, you want to leave that type like as plain as possible. Like it's just a data bag. Because who knows,
I
one
mean,
day
it
you
would
might
be
wanna-
nice if we could just say time that time here, but the API we're talking to does not give us the time in the right format.
Yep.
We might be able to have a way playing with the JSON package to get it to actually work, but it seems like something that
Yeah, something I've done before is implement my own unmarshal JSON on the event type, and if it looks at time, it does something different and so on. But again, we don't want to be like we should treat the data as just pure data and worry about presentation and presentation land.
So maybe we could say define a method on an event.
Yeah.
And say like what do you want to call it? It's basically the human readable version of the time.
How about human time?
Human time.
Now it's been a while since I don't really do a lot of Go templates, so I don't know if that's going to work if you can just call a function like that. So we'll see.
Let's find out. So this takes an event. Human time, no arguments, returns a time.time, or a string. It's a string.
Yeah.
Not in Ruby. Do that.
Yeah. So just pass back. Yeah. Let's see if we can get that. We'll learn a little bit about Go templates together.
Cool.
Look at that. Cool. That's super neat. So now it's just a matter of updating our human time.
Yeah. So this becomes e dot time, which is in a Unix. I'm not sure if it's. We always have to look at this to see if it's like.
So there was that a time.unix
Yeah.
function. Could we
I don't know
use
if it's
that,
in
you think?
seconds though, or in like nanoseconds. So let's just try like like time.unix, where we give the N64 as
Yep, and then
seconds,
0
not
nanosecond.
nanoseconds. And then if it's nanoseconds, we'll just switch it.
Okay.
This is just not cooperating with me. Let's kill all of that.
So, it
So
does
we
it
convert it
blend.
to a time, and then we have to format the time. And how do you want to format it? Just like
Just do-
2017,
Yep.
or I want
Yeah,
to say
that's cool.
March 3rd, 2017.
Sure. And let's give the time of day too.
Yeah. 2:30 p.m.
Cool.
Exported function. Yeah. Okay. Whatever. So human time will returns. Sure. Alright.
Oh, you got a little crash back there. So if you
Oh,
go
you
back to
have to
the
give
units,
it a
just give it a
0.
0. Yeah.
0. It's kind of a weird API.
Yeah. All right. How does that look? Look at that. Looks great.
I do like Go and the format method. You just give it an example, and it's like, yeah, I'll figure it out.
Yeah. Although I'm a little bit confused.
Yeah.
Some of these look like they're far in the future, and it looks like it's all March.
Okay.
And what month is it anyway?
So maybe I'm doing this wrong. So let's go to time format.
It's something like that, I think, though.
Oh, that's definitely not what I want. The world is not
Yeah.
Go only.
Turns out Google doesn't just search the world you want.
Alright. So I remember seeing some examples. Like, you do it like this.
So there's an example here. Super helpful if any Go core team is watching. I really like these examples. I think the survey they did recently highlighted that we needed more examples in the standard library documentation. It seems like you got pretty close, although I wonder if it's just, I mean, if you change it to January, for instance, like just take this verbatim, right? Like that's pretty close to what we want.
Sure. Do you care about time zone? I mean, everyone should assume we're Mountain Time, right?
Yeah,
It's
I
Colorado.
hope so, yeah. Although that's an interesting question. What time zone will it assume? Probably assume server time zone. What time zone would it do by default?
Probably the locale of what the meetup event is.
Let's see. Let's see. So I
Do you
think
want to
we,
lead the what was it, MTC that they had? MST? Mountain Standard Time.
standard time. Let's see what that looks like.
Alright.
You're gonna have to.
Just gonna do it over here.
Sounds good.
Projects. Where was it? Did we build it?
Yep. All one word.
Source. Gopher's
Website.
website.
Cool.
See, that was the HTTP request I got in before though. Told you it's possible.
It is possible.
Alright, so this looks right?
9 o'clock, April.
It's DTC 1700, which is 5 o'clock. April 1st, so that is that 9? 10, 11.
Yeah, 9. That is 9. So it looks like we're kind of all over the place in the times. So maybe our format's not quite right.
I mean, this one looks right. DTC Go Meetup. It's the DTC and the Boulder one seem correct. They're both 5 o'clock.
Yeah.
But this one says 9 o'clock.
Yeah.
For the Go monthly meetup. Maybe their time zone? No, it says it's MST though.
But it's all MST, and right now we're in daylight time. So I would have expected to see. Well, for one, I would have expected to see. What are we? May. We're in May right now. I'd expect that the DTC folks would probably have one in May, or no, we're in June. Sorry.
Oh yeah,
June or July.
All messed up.
So we still don't have this format right. All right, so maybe we go back and actually read the docs instead of.
It's weird because like March here. How about we just do like the example that they gave us so they know that it's correct.
Yeah, that sounds good.
It's definitely not it. Let's see, I have it somewhere here. There's a const too for this. I'm gonna use that.
So it's still reporting the same
Alright,
stuff.
So I think
Huh.
the problem we have here, I'm gonna undo this to go
Alright.
back to here. I think this just needs to be like this.
Oh, because we're getting it back in nanoseconds rather
Yeah.
than.
I mean, it was all over the place, so that's the only thing I can think of. No, it's still December 13th.
Huh. All right, so let's do a couple. Let's take a couple steps. First of all, let's figure out if these are actually what this is right now. So if you say, if you just kill this and go, oh shoot, how do you get a Unix time and date? Do you know offhand?
I just used the internet.
Oh, okay, let's do it.
So there's like Unix, epoch, converter, whatever. this guy. Is this the one? Yeah.
Yeah, that'll do it. All right, so we're about
you
there.
can see there's like no zeros here, but then when we paste in the thing Meetup gave us, it has like a bunch of
Yep.
zeros.
Yep. So I bet
So this is for June.
May 24th. So it's
Yeah.
little out of date.
So we do know it's in Unix time.
Okay,
here.
so that's one problem.
And it's nanoseconds. Let's go to this function here. Maybe I'm misunderstanding how this works. Unix returns local time according to the given Unix time, seconds and nanoseconds since January 1st.
Okay.
Yeah. Okay.
So nanoseconds should be good. So
Yeah.
tell you what, let's get rid of the.
Like the format specifiers are on here.
Yeah, I think maybe it's our format specifier.
Let's try this. This is the example that we gave. Let's try that. It's all December 31st.
Hmm.
Hmm.
So we got something a little off here. So let's go take a look at our format.
I'm going to, before we do that, because it's weird that before when we were just outputting that integer, it was like a perfect valid date.
Mm-hmm.
When we took that integer, we passed it to this Unix function and gave us back a time object, and then we formatted it and it came back weird. So maybe it's just the format.
Yeah, let's go take a look at the format.
There's a time.unix date, which I think give us back that integer.
That's cool.
So let's try running that.
Just to see if we can get the data we expect out.
It's
still messed up. All right, so tell you what.
Do we have to do the seconds and then also the nanoseconds in addition to it?
Yeah, maybe that's it. Maybe that's exactly what it is. So maybe what we need to do is we need to take that time and just divide it by what are nano? Is it billion?
A million?
Million.
So it'd be seconds, milliseconds, microseconds, nanoseconds.
Yeah.
So it'd be 1,000, million, billion.
Billion. Yeah. So let's divide by a billion and get the number of seconds
10,
here.
So 1, 2, 3, 1, 2, 3. It seems hackish.
Yeah, it does.
So that's a billion. So this will give us back our seconds.
And let's give it 0 nanoseconds because we don't really care about it.
Maybe they're not nanoseconds. Maybe that's the problem. Because if you look at it, the epoch thing that we had up earlier. Like if this is seconds and this is how many, what's the width of this? So that's K, mega, giga, so it's in the giga range. And if we take one of our examples here, and it just might not be as precise as what Go is used to dealing with. So you can see this is about the point here. Actually, sorry, let's do. So it looks like it's, that's seconds, it's in milliseconds instead of nanoseconds. So we could probably get away with just dividing by 1,000. Like we don't care about milliseconds. So
No, we really don't.
it's not a precise thing.
It's
I
an
think we can just
interesting API choice.
divide by 1,000, and then see if that gives us a good result here.
It's an argument to use that ISO standard for dates.
Yeah. Oh, is there a thing going on? Oh. Bind address RUs. Kill psaux rep main. Kill this guy.
Yeah.
I don't know why it didn't die.
Oh, we might have suspended it a moment ago.
Oh, did
why.
I?
Yeah.
Alright, sorry about that.
That's all right.
Alright.
All right. June. That looks correct.
So we got March, April, May, June. So they're not ordered correctly though. Doesn't look like it. June. Oh, but these are next year. This is 2018. Okay.
Yeah.
So it is
we're-
ordered correctly.
Probably a,
Cool.
a sign that in our design that maybe we want. So we're not exactly super active in the meetup world over here. But what, these are maybe once a month. These
Yeah.
events.
Yeah.
Like, it's not like once a week. So we probably just show the next 3
Yeah,
months worth or something like that.
Yeah.
But anyway,
I was thinking just show like 3
Yeah.
in the UI.
or even 3 meetups. Cool.
Yeah.
That looks good. So there was a little bit of stumbling around, but we got it. That's cool.
Yeah, in the Go world, like I'm used to using nanoseconds and seconds, but milliseconds isn't something I really deal with a
Yeah.
lot. So it's kind of weird getting that back from the
Yeah,
Meetup
it's
API.
a little bit of a different API than what I'm used to. So
What's funny is like all the Meetup values that came back, they all have zeros for the milliseconds. So they're not even giving us precise millisecond.
yeah, I wonder why that is.
Yeah.
Huh. Anyway, that's super cool. So there we go. I think maybe that's probably a good place to stop.
Yeah. Did you want to show the PSD before we?
Yeah,
sign
so
out?
we've got this kind of like bare bones data being served up from the Meetup API. We're doing it through a cache, which is pretty cool. The next thing to do is actually make this look like a decent website because I like data, but it looks a little rough.
Yeah.
Looks a little rough. So here's what we got.
Here's the big reveal.
Yeah, ta-da.
So this is just the layout that we came up with. We have a designer that worked on this with us because we're not competent designers.
Yeah, I mean, from an engineering perspective, we're done. So
Yeah.
it looks great to me. Completely
So,
information.
like I was saying, just like have 3 of the next meetups. We might want to do something where we select one from each of the 3 meetups.
Yeah, cool. So in case you want to go to all 3, you know what time it's
Yeah, or like if Denver has like 2 events, like maybe I don't know.
There's
I don't
all
know.
sorts of interesting things here.
Yeah.
But we're going to make it look a little nicer. We're thinking about maybe adding some videos from the meetups with future. You know, there's a lot of things that we could do. But
Yeah.
I think probably when we come back the next episode, we're going to have something that looks a little bit closer to this.
Yeah.
Maybe it won't be
Less-
quite pixel perfect. But
Plus Times New Roman.
yeah. So
All right.
that's it.
Yeah.
All right. See you next time.
Yep. See ya.